So this panel's about beyond carbon. It's about understanding levers and impacts in decision making, taking a lens that's wider than just a single metric. So we're looking at full planetary impact. So biodiversity, we're looking at water, we're looking at critical raw materials, we're looking at social impact and justice. The reason that's important is far too often carbon becomes the conversation in sustainability. It becomes the North Star that we drive toward, and we get what I think is fairly damaging rhetoric on things like a race to net zero, where we make decisions that seem smart in the short term, but could be quite damaging in the long term. And it's following a little bit what Claire was saying there around, is it positive for the planet and for the people and our citizens? So this panel is about understanding how we make those decisions, how we identify the levers and inputs and pull them in the right way, and kind of what incentives there are around looking at that wider lens rather than just focusing on that single piece. So I'm going to get straight to it because these people are smarter than I am, so I'm going to let them take it away. So I'm going to start with you, Deborah, if that's cool. Do you think the dominance of carbon as a symbol metric has kind of almost simplified sustainability to a level that's damaging? And how do we avoid misrepresenting the true impact of our materials?
Okay, well, the short answer is yes. The slightly longer answer, if you look at carbon, it's the history of assessing carbon, measuring it in whatever form, be it operational or embodied. So it goes back to the very early days of life cycle assessment, when people didn't really know how to measure other factors very well. And that science and the amount of learning and data collection has increased really, really dramatically, especially over the past few years. But I would say at best carbon, it is an indicative assessment. At worst, it misrepresents the assessment of impact. And just a couple of examples here. If you think about a refrigerator, particularly in the supermarket, for example, a display cabinet, and you're looking at assessing carbon, because the fridge runs all the time, 24 hours a day, more or less, and it has comparatively simple electronics and electrical components. The ratio of carbon for operational to embodied impact is about 80-20, it's about 90 to 10%, okay? Once you start to look at the breadth of inputs and outputs that we need to consider to get much truer picture, thousands of inputs and outputs, that ratio shifts to about 80-20. That doesn't sound a huge shift, but once we start looking at really complex electronic products like servers, the picture is very, very different, and that's what we really need to focus on while we're here today. So if you're looking at an older, less energy efficient server, and that ratio of carbon embodied or operational versus embodied in an older, not very energy efficient server, the ratio may appear to be about 80-20. With a newer server, that operational to embodied impact of carbon might be about 70-30. But if you carry out a full life cycle assessment and you're looking at the impact of mining, the impact on water, for example, lithium has a significant impact on water. Gold mining, a lot of it's unregulated, and the actual process of mining and refining gold involves a lot of toxic substances, for example, and tantalum is virtually unregulated, but critical to capacitors in mobile phones, etc. If you're just looking at carbon, all of those sort of factors are excluded from your assessment. If you carry out a full LCA, then the impact, there's over a 4-year lifespan, the impact is about 50-50. So the impact of materials, I think, has really been underestimated for a long, long time, and we need to address that. And LCA is not an easy activity. You do need training, etc., to do it. But the other big problem with whether it's carbon or LCA, full life cycle assessment, is data quality. And there's a lot of slightly dubious data floating around, partly because some parties don't want to publish accurate data because it may reflect badly on them. But also, when you can't get good quality data for carbon or LCA work, the tendency is to use either extrapolated or, secondary source data, and your models become less and less accurate. So we really need, it's like rubbish in, rubbish out, good data in, hopefully good data out. And if you want really, really accurate results, carbon assessment isn't enough. You need to carry out full life cycle assessment.
That's mega useful. So considering then that we've potentially got, I'll call it a carbon blind spot on this point of view, from a public sector's perspective, is the government already moving away from this sort of carbon-only thinking from your experience, Richard?
It is, and part of the reason for that, particularly in this country, the Environment Agency where I work, we did some modelling, we published a report last summer. It basically showed that if we don't take action on water as this country, we'll face a deficit of 6 billion litres a day by 2050, 2055. And one of the biggest criticisms of that modelling actually is that we hadn't factored in to the full extent of what people expected around the increased water consumption of data, IT, digital, and the increased water consumption of a move to net zero, because some of those technologies are quite water intensive as well. And you can see kind of globally water scarcity is becoming an increasing challenge as, you even get nation states having tension and arguments, and in some cases almost war about access to water. You've got tension between groups like farming who feel like they're getting a raw deal across the world, getting out-muscled by different sectors in terms of getting access to water. And in some cases, you see kind of boreholes just being dug deeper and deeper and deeper, and eventually that groundwater, that aquifer is going to go, and the river systems are going to dry up. But increasingly in this country as well, the amount of water we put into supply today is about the same as it was 20 years ago. That's despite about, well, depends who you believe, but don't believe Jim Ratcliffe, but actually it's about 7 million more people in England that are using water. And that's largely because of kind of improvements in the system, improvements in the network, reductions in leakage, some reductions in our personal consumption. But an important factor in that actually was that water use by industry was actually staying stable, in some cases declining. You can see you can build Kielder Reservoir up in Northumberland in the late 70s, kind of early 80s, largely to supply a kind of a manufacturing base in Teesside, which never really materialised. But actually what we're facing now is challenges because we've got climate change kind of behaving as the models, consistent with as the models predicted, which is wetter, milder winters, but hotter, drier summers. About mid-Feb last year was when it turned dry, if anyone remembers. Driest spring on record, hottest summer on record, pretty much. So one of the challenges we're grappling with across government, and we're working really closely now with a number of government departments as well as DEFRA, is just to say, if we want to manage the water in this country effectively, and that means making sure we have sustainable supplies for business and industry and the environment. And actually, if we want to avoid just exporting a water footprint around the world where other states may be even more water scarce or more water challenged, we've got to take this seriously. And we're working, and we're starting to work really closely, both in terms of our own sustainability strategies to try and take more account of water use in the systems. It is an entirely solvable problem, but you've got to plan for it, and you've got to look at what kind of system you use, but also working across the entire sector. It's quite a hard sector, and it's great. It's a different audience for me, and it's great, but it is quite a hard sector for us to work with because it's not a sector we've worked with traditionally, and getting access to data is kind of quite a challenge. But actually, what we're seeing now is a far more consideration of water, because actually the times that you're particularly going to need water for cooling is the times it's not going to be available, and that's going to be critical for the economy of the country, really.
That's brilliant. So if we move that focus back to the sector, and I'll lean on you, Astra, if that's okay, specifically around hardware, electronics, what does get missed when we focus on carbon operations, but we ignore the other impacts? Like, what's the biggest ones you see around from a hardware point of view?
Everything upstream and everything downstream, in a nutshell. So we've had other people talking about the impact of mining, particularly the social impact of mining is significant. Availability of resources and the risk around that is significant. Geopolitical risk to the supply of those materials, actual availability of those materials is a risk. You've got 9 planetary boundaries, we're exceeding 6 of them. I think 5 of those 6, there's a pretty clear connection between technology and those impacts, to do with the way that land is changing, the way that water is changing, the way that land is changing potentially has a knock-on impact on phosphorus and nitrogen, definitely on biodiversity. So there are all these kind of things that you can touch out in the supply chain, which are getting affected by our reliance on this, take it out of the ground, use it, throw it away. Then we get to the throwaway. And the risks associated with the downstream area of electronics are arguably worse because of where we are with recycling. So if you take a server, it's made of steel, aluminium, plastic. Okay, we can do something with that. It's also got 23 of the critical raw materials in the servers, which are in amalgams, they're in coatings. They are incredibly difficult to recover. There's technology on the horizon that will recover, but it still needs scaling. And we're nowhere near a period in life where we can just assume that recycling is going to solve all our problems. It's not there. So we need to kind of think more carefully about what's actually in this stuff that we can touch, what the value of this stuff in the equipment is that we can touch, and what it costs to produce, you know, what it actually costs. Because if you look at recycling prices on components, I mean, you and I did, they're like 50p, someone's there, and it just makes you want to cry when you realise how much that cost to produce.
Yes, it's madness when you think of the commodity values in these assets that are so low but so critical. So yeah, it's a massive part of it, and understanding it from an LCA point of view is even harder because you don't 100% know what we're talking about, like how much of it, how much is recoverable. So talking about recovery then, how do we incentivise that, Ryan? How do we incentivise product life cycle decisions that are sensible, that aren't just focused on this? You've got like a waste compensation mechanism. I'd love to, I'd love to like address that and understand that slightly, please.
Yes, I think so. I mean, first I'll start with the disclaimer because, you know, that avoids any conversation or discussion afterwards. And I might sometimes look at my phone because English is not my native language. But yeah, when you look at the life cycle of products and you look at the e-waste stream, I think there are a lot of ingredients that you can take as an action point in making that a better life cycle management process. So it's not about a competition whether circular design or repair or refurbish or even reuse is the best, you know, the best way forward. For circularity, we probably need a combination of all these ingredients to make the perfect dish. And we need to leverage, depending on the development of those systems. I mean, you were mentioning about recycling is not as advanced yet to be able to retrieve those metals. So, but maybe in 10 years and 15 years that might be. So that's the disclaimer first. And when you look at waste compensation as a mechanism, it's a mechanism where for each product, I think 50% of the audience here is buyer and the other 50% is maybe putting products onto the market. So whenever you have a product added to the market, an equivalent amount of e-waste is then collected to compensate for that footprint of that new product put to market. And typically, you need to be able to collect and recycle in countries lacking a formal infrastructure, right? If you're looking at compensation mechanism, it needs to lead to additional collection and recycling. And this mechanism is a great way for a starting point, and it's a great way in addition to all those other components within that life cycle of a product. And it can be used to create closed loops.
Nice.
And I think lastly, to add to that is we were talking about critical materials. I think 5 years ago, the narrative was very much around, oh, we need to be green, we need to think green. And, you know, and I like to think we are now getting into an era where business KPIs that's been discussed before as well. It needs to make sense. It needs to be a no-brainer for us to take certain circular actions on this journey. And yeah, the narrative is now about critical raw materials. We're talking about climate change. We're talking about e-waste. That's a global problem. It's a global challenge that we have. And therefore you need scalable global solutions. Just thinking local is not going to help. So that's...
I think it's very sensible. I think it can't be done in isolation. It has to be a closed loop. And like I said, I like the idea of the compensation mechanism being above and beyond what you're producing. So you're kind of building that into your business proposal straight away, that there's work to be done at the end before you even start. So if we've gone to the end, and I think this is sort of something I think gets glossed over quite a lot, by the time we're at life cycle, it's pretty late in the day to be making a sustainable decision as far as life cycle goes. So this is where the importance of design comes into it. And how does that focus on design play into sustainability at day one, or pre-day one, I suppose? Yeah. That's for you, Deborah.
Okay, so I know Katerina in panel 2 mentioned design before, and I cannot emphasize enough how important it is in the circular economy. And we've been talking a lot about reuse and recycling and so forth, extending product life. But the thing that enables that to happen effectively, efficiently, in an economically and technically viable way is design. And so thinking about recycling and reuse is all very reactive, whereas design is the proactive phase of the life cycle. And it is the responsibility of designers to make this happen. And if you look at the waste hierarchy, things like, okay, you've got reuse, recycling at end of life, but you've also got factors like preventing and dematerialization, which means not over-engineering your products. If we're thinking about recycling at end of life, it means considering material selection. Do you look at plastics because they are lighter weight than metals, but then they're a nightmare to recycle? Many in servers, for example, can't be recycled because of the coatings that are on them for fire retardants. So do you start thinking, compromising, finding a sweet spot and using metals, which can be, in theory, recycled ad infinitum? So design is absolutely critical, and it's been very... not ignored, but I don't think the importance of the design has been discussed enough. And the other problem, of course, the big challenge is the original equipment manufacturers whose business models are built on sell new, sell new, sell new. And at the moment, the introduction of AI and various other political factors that are going on around the world, it's just opened the door to bad practice. And I feel that in many respects, we're sort of going backwards in terms of design thinking. And the industry is really focusing on design for linearity. Take, make, use, dispose. Who cares what happens to the materials? We're just going to make more stuff and just make new stuff. So somehow we need drivers to encourage very different approach to business. So rather than being an original equipment manufacturer, yes, you manufacture, but you also think about how you can remanufacture, et cetera, and change your business model and perhaps move into hardware as a service or, similar, so that manufacturers have a responsibility and can see the economic value of remanufacture and extending product life, for example.
That's brilliant. I think we understand we can design better and it's incentivized at the beginning, right? As in it's part of the business model, is that this isn't just use and then resell, use and resell. I think that's important. So if we can design better, use better and dispose better, where are the biggest gaps in policy right now between the ambition and what's been delivered? And that's kind of for you, Rich, if that's okay.
Yeah, so I think there's a couple of important considerations here. First of all, if you look at if you look at water, one of the gaps is around you see some very kind of good, well-meaning aspirations about water neutrality. Geography is really important for water, so actually it might be more appropriate to have a more water-intensive kind of manufacturing or cooling or whatever process in somewhere where water is more abundant, that might be the most sustainable option, whereas actually you might be better off using something that might be less sustainable for carbon, but more sustainable for water in a place where water is really scarce. So I think that the one bit that I see missing at the minute is a real focus on geography in design, in terms of the systems you use and the processes that are used as well. There is a gap. We did some work with Tech UK, and there are some fantastically water efficient processes being used by lots of part of the sector. But it doesn't quite marry up with what water companies are hearing about, some mad requests for water. And I think it's just because it's such a cheap commodity, then the first place they go to is let's just see what we can get. And I think there's got to be a gap between actually thinking what is the most water efficient, the most appropriate process that we can use there. And then the other gap, which is a challenge for me, is that the water resource system in this country is made up of 15,000 abstraction points, hundreds of gauging stations with vast amounts of flow data, quality monitoring data sets. So the whole system is ripe for modernisation. So I think actually there's a huge opportunity for us around particularly digital to actually optimise our use of water resources in this country through designing that whole system better.
And the ambition's there? You think the ambition's there?
The ambition's there, the capital isn't there. The capital isn't there, and that's our challenge, because the capital of the current system is paid for by existing users. So how do we bring that in to modernise a system that we can't necessarily guarantee people will, you could invest, but you can't necessarily guarantee you've got the water, but it'd probably be a broader benefit. So that's the challenge, I think, for us.
I think that's what we're talking about throughout this whole thing is incentive, isn't it, really, as we're going through, like the incentive for capital. There are other incentives though, Astrid. So like when we talk about a full impact view, that full transparency becomes quite powerful for governments to understand the necessity of making decisions, right? I'm thinking like risk and supply chain that you were talking about earlier on. So how does adding full transparency allow better incentives at government level or even at industry level?
It would help, wouldn't it? In simple terms. There are a set of metrics that exist already, which are guides specifically for the data centre sector on how you measure performance versus draw. And a lot of those are ratios everybody's familiar with. Power usage effectiveness, there's water usage effectiveness, there's carbon usage effectiveness, there's energy reuse factor, there's a couple of ones on IT. So they can provide a starting point to start saying, how do we measure effectiveness across the board? But one thing they're not measuring is why we're doing things. And this is something that we had in the previous panel articulated beautifully. That is the first rule of sustainability is don't, right? That is the first rule of sustainability. If you have to, what is the benefit over the cost? I was speaking to John Summers at Rise. He was saying, well, what about GDP over kilowatt hours? That kind of expresses when you're using digital services, what's the value that it's delivering over its actual energy cost. You could use that concept and apply it to water. You can use that concept and apply it to other metrics that, affect biodiversity, for example. It's complex. It requires systems thinking. It requires a thorough understanding of planetary boundaries, carbon, LCAs, all the rest of it. And it probably involves an ability to say, okay, 80% is good enough. So, get as much data as you can, get the concepts right and build outwards from there, because you can't wait until you've got all the data. So I'm hoping that can...
Yeah, I think so. I mean, in simple terms, the risk is not having the right data to make the right decision, right?
Yeah, and I guess it's on us as a society to decide what's important to us. The easiest way to do that is to look at risk right now. Water is a risk. Energy is a risk because you have to build it out. 50% of future energy usage, according to the National Grid yesterday, is going to be in data centre builds to, build our software functionality. If that is true, why are we doing what matters to us? What do we want to get out of it? and what's the cost going to be?
And what's the trade-off, right, as well? Like you were saying earlier, Richard, like you win on water and you lose on electricity. But if electricity is a constraint, tough luck.
And I guess the other hopeful thing is that there are technological ways of borrowing materials. You know, the first law of thermodynamics says we don't lose energy, it just gets transferred into a different form, which is what leads on to heat reuse, combined heat and power, all that thinking there. If we could start thinking of materials in the same way and ourselves as custodians of those materials, and obliterate the idea of waste and resources and just think about it in terms of materials, then maybe we're ingenious enough to create a better world.
That's brilliant. So we've about 5 minutes left to go. I love a case study. So Ryan, can you give us lessons learned by governments from your practical experience and where this has kind of tied itself up and it's become actionable?
Yeah, I think the lessons learned are about, you know, whenever you're in a procurement function and let's say you're procuring end user devices, are you then all of a sudden having to become a sustainability expert? That is very tough. And how do you convince your colleagues that, you know, you're going to be on this journey? So I think one of the lessons, I mean, using e-waste compensation as a mechanism, as a starting point, it's something that's relatively easy to do. It's explainable. You know, why do you make someone else at the end of the journey that, you know, has the least economic benefit responsible for the disposal of a device? Because specifically high value end user devices, they travel all over the world. You know, this is a global market. This is not a UK market, Dutch market, German market, where all the devices stay nicely inside the border. This is going cross-border, etc. So the lessons learned for public procurement officers using the services, it needs to be easy, it needs to be low risk, it needs to be easy to implement to get started. It's not an end point, it's not an end game. And if something is easy to start with, and it can flex with other initiatives, and you can communicate about it because it touches on, you know, we were talking about end user experience. If sustainability is a great end user experience, also for procurement officers, they are more likely to continue also with the more difficult stuff. And therefore, you know, I think this is one of the biggest lessons learned, that it's scalable, it's compatible, and you can plug it in, and it's an easy way to start. And in doing so, you also need a standard. So one of the things that we've worked on together with TCO is developing a standard, because you need to be able, in public procurement, you need to be able to refer to standards and transparency and those kinds of things. So if you can create that as a definition, then that's a great lesson to start with. And from an impact perspective, just to close off on, because ultimately the topic is beyond carbon, when you start talking about it and you start talking about, well, actually, you know, these devices travel around the world, and actually what you're doing by using this mechanism, the biggest impact you make is that you show your colleagues that you can actually start with something. That's probably by far the biggest impact, the indirect impact. Secondly, the impact is in social value. It leads to funding of local collection and recycling, and therefore there's a huge economic benefit in those countries, you know, in the global south. And obviously there's a health and environmental benefit. And you can't put numbers straight away to it, but it makes sense when you tell the story. And people say, well, actually, this is enough in doing this. So I think that's the lesson learned that they learn.
Yeah, it's to build into a story that they can get behind, right?
Exactly.
That touches all those areas. It isn't just, it's a number and it's carbon and it's conceptual.
It's too
else.
abstract, and this is something that they can take home to their end users and say, well, actually, this is something we're doing because we have that ambition, but we also need to do something now. Yeah. We can't just design for the future continuously. We also need to do something now. So I think that's one of the lessons, yeah.
Brilliant. We've got about 1.5 minutes. So final question for everybody in 20 seconds or less. What's the one message you want the audience to take away? And we'll go that way.
Okay, design for circularity. Otherwise, we're just going to be making the same mistakes over and over and over again. So, okay, we're thinking about circularity, but actually the best way to break the circle of what's going on currently is to change design.
Beautiful.
Be hopeful. I think that this conversation's becoming more and more part of mainstream conversation, and that's a good thing. Carry on.
I guess the question for me is, do we collectively want to be part of the solution to managing water across the world and in this country, or do we want to be the sector that's blamed when the country runs out of water?
Yeah, I think, having two teenagers, it's very simple to me. If you can't explain the solution, whatever you choose, if you can't explain it to your children, then you should really be wondering whether you should be doing this.
Nice.
So I think that's the one.
Simple stuff. Well, thanks very much. That's a great panel from the guys. Thank you.
Thank you.
Well done.